Let we consider a complex function which is said to be analytic. If the function want to be an analytic function, it has to satisfy Cauchy Riemann condition. So dou u by dou x should be equal to dou v by dou y, and dou u by dou y should be equal to minus dou v by dou x. These are the two conditions that should be satisfied by the function. Let me see some problems related to this condition. So here, if we read the problem, let u of xy is given the real part of the analytic function. The imaginary part of f of z is asked. So we can use the Cauchy Riemann condition. Find dou u by dou x, which is nothing but 1 plus x. Then equate it to dou v by dou y. As the function is an analytic function, it has to satisfy the Cauchy Riemann condition. So we want v. So integrate dou v by dou y with respect to y. And we get y plus xy plus a constant, integration constant, which should be a function of x. Consider this to be equation 1. Using the second condition, dou u by dou y, we get minus y, and equating it to minus dou v by dou x. Again integrate with respect to x, and you will be getting xy plus constant, integration constant, which will be a function of y. So now equate equation 2 and 1, because these two indicate the imaginary part. If we equate, xy is same in both the case and y is absent in 2. So instead of f of y, we can put y. Instead of f of x, if we equate 1 and 2, we can find that it should be 0. Okay, so f of x should be 0 and f of y should be y. So what we get for the imaginary part, v of xy, is xy plus y. So, okay, let me see a next problem. Here, real part of the function, analytic function, is given. So this is the real part. What is asked is the relation between a and b, which are a real constant. So again you can use the Cauchy Riemann condition. Dou u by dou x should be equal to a e power of ax. Since the cos term is function of y, we keep a constant, equating this to dou v by dou y. So v, integrating dou v by dou y, we get v equal to a e power of ax sin by by y plus integration constant c. Since we want a relation between a and b, use the second condition, dou u by dou y, that will be equal to minus b e power ax sin by, equating it to minus dou v by dou x, and we want y, integrate dou v by dou x with respect to x, or keep dou v by dou x as such. Okay, so dou v by dou x equal to b e power of ax sin by. Keep this as equation 2. So to equate 1 and 2, we can differentiate equation 1 with respect to y. Differentiate 1 with respect to x, so that dou v by dou x, because why we are differentiating this term with respect to x means sin by in term 1, and here also we are having sin by in term 2. So it will be easy to equate this too. So we are differentiating dou v in equation 1 with respect to x. So what we get is a square e power ax sin by by b. So equating equation 2 and 3, you can see here sin by get cancelled, e power ax get cancelled. So what we get is a square equal to b square. So we can write the relation b equal to plus or minus a. So this is the relation between b and a. And next problem, similarly, they have given the whole function, analytic function f of z. Real part and imaginary part is present. And they have asked the value for a. So it is an easy problem. So again, you write the real part. U of xy. Real part is, this is the real part. 2x plus 3, x square minus y square. And the imaginary part b of xy will be 2 3xy plus ay. So now you can differentiate dou u by dou x. We get 2 plus 6x. Differentiate v with respect to y. You get 6x plus 2a. Okay, as these two should be equal according to Cauchy Riemann condition, we can easily write a should be equal to 1, because 6x in first term we are dou u by dou x we are having 6x, dou v by dou y we are having 6x. In dou u by dou x you are having 2, and here you are having 2a. So a should be equal to 1. And let me see the next problem. The imaginary part of the analytic function is given. The real part of the function is 0 at the origin, and they have asked the real part of the function at 1 plus I. So this is somewhat different problem. Let me see how to use the CR equation to find this value. So V is given. Let me use the CR equation. Dou V by dou Y. We get 2x plus 3. And this should be equal to dou u by dou x. So to find u, you have to integrate with respect to x. You get x square plus 3x plus an integration constant which should be a function of y. Write this as equation 1. Similarly, dou v by dou x, you get 2y equate to dou u by minus dou u by dou y. Again integrate with respect to y, you get u. It will be minus y square plus g of integration constant which should be a function of x. Equation 2. Since you can see the equation 1 and 2, it's somewhat different. Two terms are different. We have to equate it both the terms. So what we can do here, differentiate this first term with respect to y, that is find dou u by dou y. Okay, you are having only g of y, so you get dou g by dou y. And equate with to equation 2. If you are equating it to equation 2, you get where g of y will be equal to minus y square plus c. And you can write now your u of x as x square plus 3x minus y square plus c. Now at origin is x equal to 0, y equal to 0. You get u of xy is 0. So substituting it, you get c equal to 0. Now at 1 plus I term, that is x equal to 1 and y equal to 1, here your what happens to u, that is the question here. So substituting the value of 1 in x square and 1 in y square, y term, you get, and the c is 0, c term becomes 0. We get 1 plus 3 minus 1, which is equal to 3. 3 is the answer. So using Cauchy Riemann condition, we can get the imaginary term, or we can get a constant present in the u term or v term. Okay.